Let's make up an argument. Let's say that if it's raining outside, then I will watch TV. Then let's say it's raining outside. The conclusion that we can then draw is that I will watch TV. This first statement here we call premise 1, and this statement here is our second premise. Now let's write this out symbolically. If we say P is the statement it is raining, and Q is the statement I'll watch TV, then premise 1 can be written as if P, then Q. If it's raining, then I'll watch TV. Premise 2 can then be written as P, and we can conclude from those two premises that Q will happen. These three little dots right here is a symbol that means therefore, and we've just demonstrated one way to write out an argument symbolically. Let's say instead that we start with the premise, if P, then Q. If it's raining, then I'll watch TV. Let's say our second premise is not P. That means it is not raining. Are we allowed to conclude that we will not watch TV? Well, no, you might actually decide to watch TV even if it isn't raining. This common misconception in logical arguments is called the fallacy of the inverse. And while this one seems pretty obvious, it has a name as well. It's called the Law of Detachment. This Law of Detachment is a valid argument, whereas this fallacy of the inverse is an invalid argument. These are the first two of several forms of argument. Some arguments are valid, some arguments are invalid. Let's look at another valid argument. We start with if P, then Q. If it is raining, then I watch TV. And let's also assume not Q. That would be I don't watch TV. Then can we conclude that it is not raining? Yes, if the rain always leads you to watch TV, then if you're not watching TV, it must not be raining. This is called the Law of Contraposition, also known as the contrapositive. Let's look at another invalid argument. If P, then Q. If it is raining, then I'll watch TV. Let's assume that Q happens. Can we conclude that P happens? In other words, I am watching TV. Can we conclude that it is raining? Well, not necessarily. The initial statement, if it is raining, then I watch TV, does not mean that the only time you can watch TV is when it's raining. You could choose to watch TV for some other reason. Therefore, this argument is not valid. We call this the fallacy of the converse. Now, there are several other standard forms of argument besides these four that I've introduced to you. Each one of these standard forms of argument can be proven to be valid or invalid using truth tables. Let's just do one example, and then we can talk more about this in class. Let's do a truth table for the Law of Contraposition. Now, we can always start with our statements. We have two. We have P and Q. Now, what we're trying to test is whether starting with the premise P, then Q, and the premise not Q, whether or not that logically leads us to the conclusion not P. Now this looks kind of complicated, but let's run through it. We'll put in all of our possibilities for P and Q. And now let's start with our innermost set of parentheses. P then Q is a conditional, and the truth values of a conditional we gave a couple of videos ago, but those conditional truth values are true, false, true, and true. We're going to take those truth values and then compare them to not Q using this and, or conjunction. So let's first come up with our not Q column. We're going to negate all of our Q truth values. And now we're going to compare these two columns that we just created using an and. Again, you can go back to your basic conjunction truth table, which says that we only get a true if we're comparing two true values. So our results are going to be false, 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 and true. Now we're going to take this result that we found in this column and compare those with not P. Well, to get our truth values for not P, we have to negate our P column. So that's false, false, true, and true. And now we're using a conditional to compare this column with this column. Going back to our basic conditional truth table would tell us that we get a true, true, and true. So our answer column is filled with truths. We have ourselves a tautology. Therefore, this law that we call the Law of Contraposition is valid. All right, so that process seems a little bit messy to me. So I think in this section, we're going to focus most of our attention on these standard forms of argument. I've introduced 4 of them here. We're going to talk about more of them in class. So I will see you there.